And we look at this work example. Now it tells us that a bike rider of mass 45 kilos is coasting at 7.5 meters per second. So that is, we're going to consider that the velocity along level ground, and then starts up a hill. So this is what I would recommend. You do is draw yourself some kind of diagram. You don't have to have a dodgy bike rider like I have, but somehow or other indicate what's happening. So here in our system, so this is my closed system, and there's going to be conservation of energy. The total energy of the system then is equal to the kinetic energy down here. So I've got E, I can call it, like I said, either total or it can be mechanical, is going to equal the kinetic energy plus the potential energy. Now because we are at the bottom and we're going to assign a value then of 0 meters for the base, then my, if I substitute in here, half mv squared plus mg delta h at the beginning, okay, so this is the beginning. Because this will be the total energy of the system, I don't have, my height here is 0. So when I substitute in here, that's basically what I've got, isn't it? Total energy of the system will only be from the kinetic energy because my height is 0. That'll end up giving me a value of 0. And so this tells me it's 1265 joules. We want to know the height that it's possible for the person to reach before stopping. And we're going to ignore air resistance and friction. So what we're saying then is that all of the energy of the system will now be potential energy. So we'll have no kinetic energy. So at the end, we have no kinetic energy. And all energy has been transformed to potential energy. So that at the end of when the cyclist finishes this thing, we've got 1265 joules is now going to equal mg delta h. And I can substitute in, 65 is equal to 45.0 times 9.81 times delta H. So I'm just going to need to divide by those numbers. It tells me the change in height. And according to the booklet, that is 2.87 meters. Okay, so this is a transformation of energy. We've transformed it from kinetic energy, because the cyclist has motion in the horizontal plane, into potential energy, where they're now up the hill but stationary. Okay?